Hi, this is a very short video on the second cell of the three-cell model. The second cell is called the polar cell, and let's get into it. The polar cell is from 60 degrees north to the North Pole and from 60 degrees south to the South Pole. It is the northern cell in the three-cell model in the Northern Hemisphere. It is the other thermally driven cell. In other words, that it is driven by warm air convecting up into the atmosphere, then moving toward the cold air and the lower pressure. In this case, we're talking about air that is relatively warm at 60 degrees latitude, which is quite far north. But it certainly is warmer, and it's warmed by many ocean currents that have come up from the equator and that really retain their warmth for quite a bit. Think of the Gulf Stream warms Nova Scotia and Prince Edward Island up until long into the winter. So these ocean currents can really still warm the areas around the 60-degree parallel, especially when you're comparing that to the temperature at the North Pole, and that's what we're looking at here. So these areas can still warm and convect up and start a thermally driven cell. Let's look into it a bit more. That warm air convecting will equilibrate with the cold air that is over the North Pole. So in other words, we have warm air that's higher up than the cold air at the pole. Wants to equilibrate, the warm air will move into the colder areas with lower pressure. And in doing so, it'll cause this air over the North Pole to sink, forming a surface high. Remember, sinking skies, warm and dry. Well, it's not really going to get warm by compressional warming, but it is certainly going to dry out over the North Pole, and then surface high. So sinking skies, warm, definitely dry, and surface high. The result of all of this movement is that we now have a surface high at the poles. And let me just get my mouse over here. There it is. We now have a surface high at the poles. Remember, we have a circulation of air. The surface high is going to move into the area that lost all of its air molecules in going up and moving over in circulation. So this has now become a surface low, and it is completing the third cell here. Remember, this surface low will be called a subpolar low, and it is the result of our mnemonic that says rising slow, clouds and snow, surface low. By moving that air out and up and over to the low pressure zone in the atmosphere, we are effectively taking air molecules out of the column here, creating a surface subpolar low. So, to remind you of everything that's happening here, this is a second thermally driven cell, the polar cell. It evolves from 60 degrees north. It moves over to a polar high right over the North Pole and then completes its circulation there. Let's find out the ramifications of this very important cell and its effect on the jet stream. That's the next slide. Well, the next video.